Hello students, this is definitely my last video on circular motion. Okay, I'm here with the question number 9. Now in this question we're given that there is a particle which is released from the point A from rest. So we have the initial speed as 0, and then this is a smooth kind of a cross section of a vertical circular surface. Okay. This angle is given as 45 degrees over here, so this is going to be basically rotate up to an angle of 135 degrees. So we'll find first of all that what would be the speed of the particle when it is just going to leave this circular track at point B. So let's start the solution. So as you know that we always start by seeing the energies, the sum of energies initially and the sum of the energies generally. So initially, right now, since this is the level from which we're going to determine the potential energy. So you see that initially we have potential energy that is equal to 0, and since we are releasing this from rest, so the kinetic energy will also be equal to 0. Okay, so the sum of energies is going to be 0 somehow. So that means that at whatever point you determine the sum of the energies, that will always be equal to 0. So now let's see what happens generally. Now suppose this has been rotated up to an angle theta over here. Okay, and the particle is right now over here. Let me show its weight. This is the vertical line. Okay, so the weight is going to be mg. Here is the normal contact force. Okay, and when let me erase this, so you guys know that this is the TE is 0 and KE is also 0. Okay, now let me resolve this weight so that I can determine this R over here. Before I resolve this weight over here, let me write what is happening generally. Like here at this moment the speed is going to be V. Okay, so generally let me say the potential energy would be, if I am able to determine how much is this length over here, we know that this is the radius, which is A, and this time this is going to be A sine theta. Okay, this height over here is A sine theta. So the potential energy at this general point is going to be minus AMG sine theta. So that is the potential energy with us right now, and the kinetic energy will be half mv square. So if I let me write this at the top over here, but through the conservation of energy, we can say that the sum of these energies, like this, half mv squared and then minus AMG sine theta, that is equal to 0, because the sum of the energies is initially 0. So you know that we always need that for, like, when we apply this F equal to MA, so this becomes mv square over R, and R is A right now. So let's find out this this thing from this equation. So this is going to be mv square equal to 2AMG sine theta. I want to make it mv square over A, so this is going to be A, and this is going to become 2mg sine theta. Okay, now let's come back to resolving this weight so that we can have the net force acting towards the center. Okay, now this angle is theta over here, and this angle is going to be 90 minus theta. Okay, so when I have to resolve this like this, so this angle will be 90 minus theta, and this angle will be theta now. Okay, so therefore this component opposite to this R is going to be mg sine theta. Okay, now coming to this f equal to ma thing, so we have this r minus mg sine theta. So this is my relation number 1, and here is the relation number 2, and you see that we have these two relations over here. So from 1 and 2 we can have this r minus mg sine theta, r minus mg sine theta, that is equal to 2 mg sine theta. Okay, now we are quite aware of the fact that when it reaches the point B, then this theta is going to be 135 degrees. Yes, do you agree with this? Like, you know, all the way from this to this position. So this like, to determine this, first of all let me write this r is going to be 3 mg sine theta, and you know that what is sine 135? Yeah, that is under root 2 over 2. So this r is going to be 3 under root 2 over 2 mg. Okay, since we have to find the velocity at the point when it just leaves this circular track, and we know that that is the point B, and at the point B we have just determined the value of r. Now let us use this value of r to find the speed. Okay, so I can use this equation number 1. Okay, so in this equation number 1 I have got this r, so I'll be changing this r with 3 under root 2 over 2 mg, and if I put the value of theta, which is 135, so I get this as minus under root 2 over 2 mg, and that is equal to mv square over a. Okay, so when I simplify this, I will have, okay, while simplifying this equation, I'll have 2 under root 2 over 2, so that means this is going to be under root 2 mg, that is equal to mv square over a. I can cancel this m with the m, so I have v square equal to under root 2 ag. So this v will be square root of the square root of 2 ag. So guys, this is the speed of the particle when it just leaves this circular track. Okay, now in the second part is asking for the what does it ask? It says find the greatest reaction force. You see that the greatest reaction force would be where, if you look at this equation over here. Okay, so the greatest reaction force would be there where the sine theta is greatest, and you know that sine 90 is 1. So that means if I can show you this over here, when the object reaches here, so here that r will be greatest because this angle is right angle 90 degrees. So if you put that sine theta is 1, so the greatest r would be 3 mg. Okay guys, goodbye from this chapter on circular motion. I hope you enjoyed, and if not enjoyed, you learned something from these videos on circular motion. Thank you very much.